exceeding our number of participants that we can allow in our Zoom account. That doesn't happen often, I must tell you. It seems like roasters using Giesen or looking at using Giesen roasters are okay. So we are now also live on YouTube, and those that are trying to log in to the webinar and find that they cannot access because there's no more room in this webinar session, then they can follow this webinar on YouTube as well. So that's really cool. So I'm going to share my screen. Let's see, here is my, yeah. So, and then let me put this in play. So this is today's list of discussion topics. First, we start with the basics of heat transfer. Then we will go into air pressure profiling. This is, of course, a feature that Giesen machines offer. As far as I know, Giesen roasters are the only roasters where air pressure profiling is really a parameter that can be used to create profiles. We will do some live roasting and some live cupping. And some of these interactions here, Marcus and I have been testing this all out, but we might still occasionally have some hiccups in our technical capabilities. This is myself, this is Marcus. We combined, we have, you know, I'm not exaggerating, half a century of coffee experience. That sounds very scary, but at the same time, it sounds really cool that in a lifetime of coffee, you're able to go this deep into roasting, into cupping, into quality management of coffee. I started roasting very early on. My first Giesen roasting experience was about 15 years ago. On one of the very first machines that Wilfred Giesen built. And I was, immediately kind of blown away by the capabilities of Giesen of conveying heat, of bringing heat to the coffee, and the ability for the roaster, for myself as a test pilot, then to be able to modulate that heat transfer and to modulate the rate of rise. And that, I think, as a phenomenon where Giesen's ability to do this so well, that is a powerful thing. Over the years, Giesen has been able to develop certain features of their roasting machines to a deeper extent. They have been true and loyal to their original concepts of building roasters, which means, powerful motors, powerful fans, and cast iron. And I've been a very strong advocate of cast iron because of the fact that I like cast iron so much as a heat transfer medium. And I can elaborate more on that later. So when we talk about heat transfer, then this is of course basic stuff, but it's always good to start with the basics. When we talk about heat transfer, then we're always discussing the transfer of heat from a hot source to a cold or colder medium. In this case, the source is the burner and the medium is the batch of coffee being roasted. When it comes to using gas burners, whether it's propane, natural, or butane, or any other biogas, then you're always aiming to create like a gas mixture, a gas air mixture before this mixture produces a flame. Obviously, we have other heat carriers that can be electric burners. There are different configurations in that. There are different types of burners that one can find also on bigger machines, like a power burner. But in this specific case, we are looking at burners that usually are so-called ribbon burners. And these are burners made on a, hey, Marcus, could you pass me one of those ribbon burners? Yeah. I pulled out a ribbon burner from one of the Giesen machines. Here you see the ribbon burner from a W6, I believe. And these are, the individual segments of these burners are made with high precision equipment, which allows that each of the segments of the burners produces exactly the same amount of heat output as the other sections. This is unlike burners where you would have jets or where you would have the older style ceramic nozzles, which you can find on older German roasters. Those are not necessarily always that precise. These ribbon burners that are made in this way, they allow for very precise control of heat. And that's also very powerful in the case of where you need to adjust your gas pressure in order to get the right flames. And so I think this whole topic of heat transfer, of course, leads into the discussion of what type of heat transfer do you want to produce? Are you looking at conductive heat? Are you looking at convection heat? Are you looking at radiation heat? And in each of these heat transfer principles, conduction, convection, radiation, will have its own outcome on the roasting process by itself. And so if we first define, what is conductive heat? Yeah, of course, conductive heat is the heat by touch. So it's the heat that you perceive when you touch something, right? And so conductive heat is the heat transfer process in which we are transferring kinetic energy of the burner to the material, to the medium, to the coffee. And that can be through direct contact between the hot surface of the drum to the beans. And as you probably know, most Giesen roasters have double wall drums. Or it can be direct contact between the beans themselves. So conductive heat in that way can be drum to the bean and bean to the bean. If you look at the next option for heat transfer, then we talk about convection heat. So what is convection heat? Practically, it's the heat that we transfer through preheated air. And with Giesen roasters, like with other roasters, but with Giesen roasters, there's ample opportunity for air to pass the burners before this hot air is fed through the roasting drum, through the coffee. And as you probably know, those of you who have been looking into their Giesen roaster or into the roaster they use, most drum roasters have a perforated screen on the back through which that preheated air is channeled. And then in the drum itself, we have a mixing going on where the the rotational direction movement of the drum will allow the beans to rotate, and also the vanes that are in the drum, these pedals, they allow the beans to rotate to pass from the back to the front. So you have two motions going on, and in combination with a good amount of convection heat, will give you an optimum mixture between the heat source and the coffee itself. And so in the diagram that we see on the lower left part of this slide, we can see a single bean surrounded by hot air, and airflow and the burner power, they're really related to the speed of your roast. So, and the speed of your roast is the rate of change or the rate of rise. And in many machines, I would say in most circumstances where you have a high flame, so a lot of heat with high airflow, that will almost always result into a faster rate of change, so in a higher rate of rise, due to the increase in the convective heat transfer. And so the opposite, if you have a high airflow with a lower burner setting, then that will have the opposite effect. That will put the brakes on the rate of rise. And so we have had conductive heat, convection heat so far. And then before I move on, we also, of course, have radiant heat. Now, with the Giesen machines, like with other machines, as you probably know, moving a machine, a roasting machine around is a back-breaking effort. So these machines are heavy. Our friends at Giesen, they are one of those culprits, manufacturers most guilty of making their machines very heavy, which ultimately, once you have moved your machine and you have passed over your hurting back, then it's all okay. Because I think a heavy roasting machine, having used the right materials, contributes to being able to do your roast very consistently. So the overall mass of your roaster contributes to that. You should try to lift the faceplate of a W15. Now that by itself is a major effort. So the faceplate, that cast iron faceplate, is very heavy. So that faceplate, together with other cast iron components of the Giesen, contributes to that radiant heat transfer. Cast iron has the property also, because it's on a relative scale compared to carbon steel, for example, it's porous. It's a porous material, so it allows to heat up more relatively. It also allows to cool down more easier on a relative scale. And cast iron has this amazing ability to reach through its radiant heat, to reach deep into, to penetrate its heat deep into the heart of the bean. So now we've had conductive heat, convection heat, radiant heat. So that's, I would say, as a set, as the three musketeers of heat transfer, these three, ideally as a roaster manufacturer, you want to be able to give the user the optimum options to control these three sources of heat. And I think Giesen has been very, very successful in that way. So we can actually allow the machine to behave more like a fully or almost fully conductive heat roaster. We can also, with the controls of our fans, we can allow the machine also to behave like a more fully convection heat roaster. Comparatively, in the market of roasting machines, an example of a more conductive heat roaster is like a Diedrich. So we can allow the Giesen to roast like a Diedrich, or comparatively, where it comes to the convection heat roasters, we of course have the full convection heat roasters like the Civets, or we have convection heat roasters like the Loring. So we can also allow the Giesen to roast like a Loring. So that's I would say the benefit is we have a tool. The Giesen roaster is a tool to modulate its heat transfer in ways that we can find with other roaster brands easily. So when it comes to you coming from a different brand of roasting machine and you're diving into a relationship with Giesen, you can actually allow your Giesen to roast like that other brand of roaster that you're used to, because ultimately that brand of roaster will put its stamp, or the features of that roaster will put its stamp on the flavor profile of your coffee. Here at Boot Coffee Campus, we have a lot of different Giesen machines available for you to try this out, and we can help you also to translate the roasting profiles you developed to your Giesen machine. So that's about heat transfer. Really interesting stuff, I think. Let's talk about air pressure profiling. Now, for those of you who participated in the previous webinar a month ago, we actually reviewed up close the Giesen control panel, and there are kind of two key screens that you use. One is the screen that has the set temperature and the burner level, and the other, maybe Marcus, is there a way for you to show the screen of the Giesen? Marcus is going to try to show this. You could also use your other phone. Okay. Let's see how well our technical abilities work here. Marcus, you have to unmute yourself if you want to talk. Yeah,
all right,
you're live.
Everybody. So, yeah, here's the primary control screen of the Giesen profiler, and we'll do some live roasting with this in a little bit. But yeah, I think one of the things that's interesting is we can load up a series of different profiles here. And when I select it,
Marcus, it's very hard to hear you apparently.
Is that any better?
No, maybe well.
Let me unplug the.
And there's feedback. So Marcus, let me take over the screen again, and then okay. Yeah, Marcus, you have your PC volume on. Right now there's feedback.
It's off.
Okay. Thanks guys for giving me heads up on the technical issues we have. But basically, Marcus was trying to show you the control panel that is part of the Giesen profiling software, about which one of our next webinars will be. But through the Giesen operator panel, you can modulate your airflow. And on the Giesen, this is done by pressure profiling. I'm going back to my my presentation. Okay, so everyone can see my screen now. Okay, so sorry. Let me reinitiate screen sharing. Okay, now I should be back, right? Thanks guys for suffering with us while we figure this all out. Um, so with the Giesen, you can run your Giesen using a low airflow profile or a high airflow profile or a combination of two. And here we have some screenshots of the Giesen roast profiling software. If you do not have this software, you can actually recreate this by just manipulating the air pressure setting, the PA setting on your Giesen. If you have a older style Giesen that does not have the PA set point adjustment, then you can literally just set your Giesen at a low airflow altogether. But the air pressure profiling, like in this slide, you can see there is this kind of jagged line at 100 PA. That's the pressure I was using in this profile. And you can see at the far end, there's a little spike that is some registration of the software, but we kept, in this case, the profile consistently at 100 PA. And then you can see the red line is the bean temperature, and the blue line is the air temperature. So the distance between the blue line, the air temperature, and the red line, the bean temperature, we call that the delta. It's the temperature difference between those two. So when I look what happens when I go from a low airflow profile in a high airflow profile. So this is a different roast we did. So now we had a roast where we had a little slightly longer heat soak, where we allow the coffee to absorb the heat of the roaster before we start with the burners on. But now we have a higher air pressure of 160 Pascal. And now look at that delta between the red curve, the bean temperature, and the blue curve, the air temperature. I'm going to switch back and forth so you can see the difference. Now, although it might seem visually, optically from your end not that relevant, this is a very relevant difference. And that is really unique. There are not many other roasters, or there aren't any other roasters as far as I know, that have this ability, unless you spend, a huge amount of money on a big industrial machine and allow engineers to figure this out for you. And this, as a controllable parameter, is very powerful, because I can do these absolute profiles, low airflow, high airflow, or I can do a variable airflow profile, where I start at 100 PA for the first 7 minutes, and then I switch to a higher PA of 160 in the second half of the roast. And you can see in this scenario, we can see at that, just beyond that 7-minute mark, you can see how quickly the delta between the air temperature and the bean temperature changes. And so that delta by itself is indicative for the fact that now we are contributing with more convection heat to the development of the coffee. Now, at the 7-point mark, my temperature was, bean temperature, you can follow that on the graph, was somewhere around 320 degrees, right? Now we know that at about 280 degrees, Maillard reactions really get going. Maillard reactions are really a key driver of the chemistry changes within the beans. And at about 310, 320 degrees, those Maillard reactions are setting in motion a process of caramelization, which is the chemistry changes of the sugars within the coffee. As you know, we have a lot of those. And those obviously contribute to sweetness. And so you can say that with the airflow pressure profiling, I have the ability to kind of control at what point in the game of roasting I can induce certain chemistry changes. And that is, from my perspective, that's like really cool. That's very, very, very cool. So obviously, you can talk a lot about these theoretic aspects, but you've got to, be able to do it, to practice it also. So we're going to actually do a live roast. Marcus is going to try to show this via his feed. First, which coffee are we using today? We are using this coffee from Guatemala, which is an interesting coffee. It's a natural processed Caturra. We cupped this coffee, and you can see the descriptors here. It's kind of a clean but fruity natural process sweet coffee. It has a winey aftertaste with a kind of a green apple flavor. Some other copper found citrics in this. It has a coffee that has like exotic notes, florals, grapes, raspberry, red fruit, strawberries, tangy. And we took some shots of this coffee, and you can see here, these are the green beans. So you can see the kind of the natural process of this coffee has created kind of an interesting texture from the outside. Overall, I did not measure the density of the coffee. Maybe Marcus did, but this is on a relative scale quite a dense coffee. How can I see that? Because I see the kind of the corrugated exterior surface of the beans. I see that the center cut is somewhat tight, somewhat closed. So that is indicative that this coffee can handle a lot of heat, potentially. At the same time, however, it's also natural. Natural coffees, you've got to be careful with too much heat. So you want to be able to potentially reduce your rate of rise quite dramatically at the 7th minute mark. If you don't, the coffee might just, as we say, run away from you. And here is the roast we did on one of the test roasts. So on an absolute spectrum, Marcus, what's Actron did we have for this coffee?
This was an Agtron 54. We did the 3 trials that we looked at the profiles from. They were all within 1 point of 54.5, so quite close.
So it was an Actron. If you mute your microphone again, Marcus, thank you. So it was an Actron 54. This is a bit darker than cupping color. When you're doing cupping color, you're aiming for Actron like 58, 60. And now we are going to go into some live roasting. We're going to demonstrate the feature of the variable airflow. And we're going to demonstrate how that can also be used to induce a faster roast with a higher rate of rise. So let's see if we can show this to you as we intend this to.
You may have to make me a co-host again, Willem, to
yeah.
share my screen.
Okay, 1 second.
All right, everybody, I'm going to go ahead and share my screen. Give me a moment to open the Giesen profiler. I did notice, though, while I do that, I think it was Mike McKim I saw asked if we're measuring those Agtron numbers whole bean or ground. those were whole bean numbers that we provided. Of course, if we were doing this as a full production operation, we would want to be able to compare both the whole bean and the ground colors. And here's my Giesen profiler. Okay. Hopefully we stay connected this time. Last time I pulled this up, I lost my entire internet connection. No fault of the profiler. But I'm going to go ahead and load a reference of that sort of low air pressure profile that we had previously. So now this is loaded up as the reference. And when I'm ready to start playing that, it will just repeat that entire profile if I allow it to. I'm going to make some overrides because I want to try to increase the air pressure later in the roast and also have a little bit of a faster roast. So I'm right about where I want to start my roasting. Give it a 5-second delay. So a couple of changes that I want to make right away is I'm going to increase my set point just a little bit, so I have a little bit more power going in to the end of the roast. Going to kind of roll the dice on this development test and see if that's too much power or if we're in an okay spot. Additionally, I was a little bit slower adding my initial gas input on this. So currently my burner is off, but I'm going to go ahead and turn my burner on here at 45 seconds. And I'm just going to use the auto feature so that the software and the profiler and the roaster will toggle. I have no doubt with the
So. Okay, I'm taking the sound over for Marcus. This is something we will have to figure out technically how to do and live roasting and how to make this audible through the Giesen machine sound. It's more the sound of the beans. Everyone can hear me fine now. If someone can acknowledge that I can continue. You can hear me well? Okay, perfect, thank you. So let me explain what's going on, because you're looking at the Giesen screen. This is the profiler software screen. If you do not have this software, or if you don't even have any type of Giesen software, if you just have a panel, then I would say, this can be recreated. This can be done also without having this software. So we have gradually the curves start to roll out. My bean temperature at this point is 220 degrees Fahrenheit. So we're just beyond the boiling point of water, which is 212 degrees Fahrenheit or 100 C. So we're now in that stage of water being evaporated into vapor, and that pressure development starts to induce distinct chemistry changes to the coffee quite soon. We see our air temperature. I lost the feed.
I know, it's totally, the internet is dead on that one.
Okay. Okay, we unfortunately our internet semi-crashed trying to do 2 feeds at the same time. But I'm going to discuss what we're doing in this roast, and I can try to ask Marcus to send me a screenshot once he's done. But basically, what we're trying to accomplish here is a variable roast. Variable meaning variable air pressure profiling, starting the air pressure, Marcus, at 100 PA and then going up to 160 PA. Is that correct? Yes. Yeah. And we're doing this as we speak. I'm looking at the Giesen roaster. You can see in your in the other window that Marcus that displays Marcus. If you put yourself in gallery view on your Zoom, then you will be able to see myself and Marcus next to it. And so, so this profile by itself can be recreated if you do not have the most modern Giesen profiling system. Okay, Marcus is back. He rebooted his, which one shall I do? You're co-hosted now? Okay. Marcus, you have to turn on your microphone so that you can try to give, or I can make comments. Let's continue with that. Yeah, perfect. Yeah, here you can see. So at what stage are we now? So we see kind of a yellowing beans. So we're now 6 minutes into the roast. This is a point where you can see we're now at 325 degrees bean temperature. And now Marcus is increasing his air pressure. So the air pressure, the higher air pressure, what does it do? It tells the roaster, tells the fans of the roaster to work harder to maintain this 160 Pascal pressure. What pressure is this? This is the under pressure. This is like a relative vacuum. So the fans now remove more air than before, and the as a result of that, the convection heat is working harder to facilitate that. So we have now, on a relative scale, more convection heat. You can see my rate of rise is still relatively high. It's 12 degrees Fahrenheit per 30 seconds, which gives me 24 degrees per minute temperature change. So that shows you if my endpoint would be somewhere in the 390s, then, or maybe 400, then that would give me at this point about 2.5 minutes to go in this roast. So now you can see through the change in air pressure from 100 to 160, you can see the increase of that delta. You can see that the air temperature has been rising, is now, it's about to rise. It's still 401. The bean temperature is 365. And so that delta, that increased delta will result into either the rate of rise staying at this level or being relatively high. Rate of rise now 10.6. Sorry? You want to talk about the 8 points? Yeah. And so now, in order to control this roast to the level that we want to get put the brakes on the rate of rise, we're lowering the burner. You can see the burner is now at 10%. And at the A point starts right before the first crack. At the A point, the pressure within the beans, now we have the first crack, by the way. So that is at 384 degrees Fahrenheit, 399 air, 7 rate of rise. So at the A point, we have the pressure within the beans, mostly produced by water vapor in combination with oils that vaporize. We can smell the very first precursors of the characteristics of the bean right before the first crack. So now, at the start of the first crack, we basically then also start to count, measure the RD, that's a roast development time. If we express it in a percentage, you can see that on the lower side of this screen, you can see it now is 9%. So it's the time that has expired between the start of the first crack and the end of the roast, or the position where the roast is right now. So we can see right now this RD is at 1 minute and 10 seconds and gradually increasing. I will answer all of your questions. Okay, here ask someone, could you tell the Celsius numbers quickly? Yeah, I would have to look this up on my phone. You can easily do that on your end also. Just Google Fahrenheit to Celsius. The load size in the roaster. What's the load size in the roaster, Marcus? He doesn't hear me because the roast is just being finished. So now we have the end of the roast. The RD, roast development time, was 1 minute 58 seconds. By percentage was 18%. Bean temperature at the end of the roast, I will ask Marcus again what it was. I think it was 408 Fahrenheit. Marcus, you want to come here and then take my seat, and then you can comment on how this roast went for you?
Yeah. That doesn't work.
Just ask them to give you a heads up about the sounds.
All right. Hi, everybody. Sorry that the sound is a little rough standing in front of the roaster, but we're working on the technical issues. So I was quite happy with this roast. You know, my goals for it were to have a faster roast. I also wanted to incorporate that variable airflow. You know, a few things that I was happiest about was seeing the way that I was able to sort of extend the roast period a little bit after yellowing, sort of even after yellowing, kind of at that phase when the coffee was you know, kind of a cinnamon color. You can see here between 6.5 and 7 minutes, the rate of rise dropped before coming back up just a little bit. You can push it into first crack.
So that pour the water so that you can do the cupping and then
yeah, perfect.
And then it'll bring it up.
Perfect. We're now going to cup the previous 3 profiles that you all saw. So that would be great. And yeah, so I'm quite happy with the way that this roast went. You know, my goal was to craft something very different than the previous 3 profiles. I think what we're going to cup in just a minute are going to illustrate 3 roasts that were very similar from the perspective of total roast time, development time, and end color. This roast, this 4th roast, is like a totally different approach to this coffee with a much shorter overall roast time, with a slightly shorter development time. We have a development time now of only 18%, It was actually closer to about 17 and a half, whereas the development times for the previous roasts were in the 21 to 22% time. I think, I haven't measured the Agtron yet, but I'm fairly confident that the roast color on this is still right there in that 54, 50.5 Agtron Gourmet. So maybe a little bit darker, as Willem said, than a cupping roast, certainly slightly darker than the roast that we would expect for kind of a light medium roast, as we often roast our coffees here. So I'm pretty excited about how this will taste. I think I have some expectations of what it'll taste like, but we're not certain. It's all what's in the cup. So I see Willem is over here. He has poured some water, and we are ready to get our noses into the aromas of roasts A, B, and C. Roast A was the roast of the low air pressure. Roast B was the higher air pressure, and roast C was the original variable air pressure. So there's roast A at 100 pascals of pressure. Roast B, very similar, but with 160 pascals. Roast C, we moved the air pressure from 100 pascals to 160 pascals at the 7-minute mark. So, for this cupping, we're going to treat it, very much as I would recommend our clients treat some of their production cuppings. To do a full formal SCA scoring might be a little bit overwhelming if you're cupping 20, 50, 80 production batches per day. But having a very straightforward, simple form that asks the tasters to assess key important characteristics of your coffee can be a great way to do that, especially if you sort of know what the reference of that coffee is. So in this case, we will take coffee A as our reference. And if coffee B and coffee C match the flavor for that, match the acidity and match the mouthfeel, we would simply put a tick mark right in the center of these scales. But in any case where the flavor, acidity, or mouthfeel are improved, we would rank it higher. If it is worse, we would mark that lower, and then we have a place to write some notes about each coffee. And I think through a system like this, it's a great way to evaluate various profiles and make a determination of which do you like the best. So we are ready to roll and break our cups.
You want to go to the coffee and then I'll take the headset?
Yeah, I can take the inboard as well.
Okay, I can bring the computer over there. It has to be reversed. Okay, perfect. So Marcus is now breaking the crust on these coffees. And let's see if I so obviously when it comes to the cupping, that is by itself the validation of the work that has been done, right? And cupping and also quality inspection, like color inspection and density inspection, those measurements are key. But then cupping and being able to do this in a calibrated way is really important to be able to continually tell that you as the roaster that you're doing a decent job, right? I see a lot of questions coming in. Let me first also dive into this coffee. Marcus, could you point that phone to my screen? So. Yeah. So A was the benchmark, right?
Yep.
Yeah. Coffee A is the benchmark. So I'm getting like on the aromatics kind of chocolatey tones. There's a kind of a little bit of a clean leather, roasted nuts. So now I'm going to B, which is the low airflow coffee, right?
A is low airflow.
Oh, A is low airflow, B is high airflow, and C is the variable. Okay. I still smell the same descriptors in B versus A. I would almost say it has become a bit more chocolatey, kind of caramel.
I agree. I thought A was a little bit flat and cereally, like cacao nibs.
Yeah.
Whereas B was much more like dynamic, like a fine chocolate.
Marcus found A more like cereal, cacao nibs, and B was a bit more dynamic, you said?
Yeah, dynamic dark chocolate.
Yeah, dark chocolate. And now I'm going to smell C. It appears that what we were trying to do in the aromatics, it appears that it was successful. By the way, sorry for the mess that I create here. I always am giving my students a hard time when they pour this badly, and boy, I was my own worst example, right?
Look at my tray here while I'm with you.
Yeah, and Marcus' tray is really clean, right? Okay, maybe that's indicative for the personalities you're dealing with here, right? So aromatics is one part. I think, don't underestimate aromatics, especially when you assess flavor profiles. But ultimately, it's really in the flavor also, where you're doing air pressure profiling trials, then I think it's essential to focus very much on the acidity that you find in the coffee. And so now I'm going to see, this is, put these out. So I'm first going to test A. So this is quite remarkable, huh? That I tasted A, that's the low airflow, the lower pressure setting, 100 PA. I still get consistent notes in the flavor as in the aroma. This chocolate, kind of like a clean leather. There's nothing bad about that. It's I also think like a dried blackberry of some sort, or a dried fig, like a black mission fig. We grow them in our yard. And then B, because that was roasted with the high airflow, the 160 PA. At that point, the fan is working harder. The acidity is much more pronounced. It seems like this coffee, it almost seems like the coffee became younger, showing less signs of age than in the case of the profile of A.
I find it's more fresh fruit.
Think of your head. I'll give you the.
Yeah, I find B to be much more fresh fruit as opposed to dried fruit. The acidity just has this really nice, crisp citric acid to it. I still also find malic acid in there, so similar to the cupping notes that we found on this coffee. Just much more dynamic. Maybe Where it is a little bit less interesting is in the mouthfeel. I find the mouthfeel is kind of thin with B, but it's still very silky. Whereas with A, it's got this like kind of thick, heavier mouthfeel.
Cool. Thank you, Marcus. So now I'm going to test C, because that's the kind of the composite profile, right? Mm-hmm. So here we've really put the Giesen profiler to work. So I perceive like this coffee has, it seems like there are more levels. In the first two examples, I had more absolute visuals when I tried to visualize the flavor profile. With A, it was more base notes, more body notes. With B, more acidity, more pronounced acidity. And with C, I get both. I get in my first taste, I taste those darker chocolate, kind of almost baker's chocolate notes. And then in C, in the higher notes, I do taste like these citrus notes produced by dried fruit, like a dried fruit upper level in that flavor profile. What Marcus just?
Yeah, I think C kind of loses the refreshing quality of B, but it does bring more.
He says, C loses the refreshing quality of B,
but it gains like a richness and a depth.
But it has a lot of richness and depth. All right, cool. This was cool. I always like it when things don't work, or when things work out.
I would prefer to drink B, but I would prefer to sell C.
Yeah. Marcus says he would prefer to drink B, but he would love to try to sell more of C, right? Why does he say that? Because C is harder probably to reproduce by your competition. So now you have with C, with that, my composite profile, you've created, really put your stamp, your signature on that flavor profile. So that was cool. There are some questions that I'm going to dive into before we close this session down. I think, given the discussions we get with these sessions, it's always cool to consider a longer roasting seminar. I'll ask our friends at Giesen if they are open for that thought. Just going to address some questions. There are some general questions on that could be best answered by the sales team of Giesen. I will channel those to the sales team. What does 18% mean? That's the development time. It's the development time expressed in percentage. You basically time from the start of the first crack, you start measuring the time until the end of the roast. So if that time is 3 minutes and your roast was let's say 12 minutes, then your development time in percentage is 25%. And so the percentage is calculated that way. The RPM of the drum, how does it affect the roast development? Great question. That's actually a topic for the webinar, I think in August. So check back in August, because we're going to do very similar trials as we did today with the RPMs. Of Ovidio Diaz asked, do you have a preference to airflow setting depending on varietal and or process? Wow. Yes, I have found that varieties or processes or coffees that that have very distinct floral notes, you obviously want to treat those coffees with sufficient airflow. So it seems to be a good principle to allow at some stage in the roast for a slightly higher airflow setting with those floral coffees. But again, you have to assess this from type to type. There's not an absolute rule to this, but in general, yes, you can say that the like a profile like we did today for this third option, option C, might very well work for floral coffees. The coffees, like Pacamara, like Geisha, like Java, and I can um, keep you busy for a few hours talking about all the other varieties of which I might think that might be done best with certain settings. That will be cool for as a topic for one of the next Giesen seminars, by the way. There's a question about the burner. The burner that I showed in this webinar is a so-called ribbon burner. Very common burner also for high-end heating devices nowadays. There's a question about Giesen versus Probat. I will channel that to David and his team. David Sutvin, who is the Giesen sales and engineer expert here in the US. I can tell you that Probat, although it's a good, great machine, I would say Giesen, this ability of air pressure profiling cannot be found on a Probat. There's a question, how about the small flick at 10 minutes 40? Looks like a flick and crush. Would this not influence the fruity character in a negative way? Thanks. This flick can also be just the result of some readings of our thermocouples. I would have to very specifically look at this profile again to tell you whether or not this was something from the coffee or something different. Usually there is a uptake or a flick, sometimes a crush, where you are approaching the A point, which is before the first crack. In this case, I'm not sure. There's Pierre asks, why in your opinion is Giesen better? Pierre, how many days do you have to talk with us about this? I would say, come and check it out with your own coffee. So if there's a Giesen near where you are, or if you are somewhat near California or near Pennsylvania, then take your coffee, test roast on a Giesen, and then test roast on any other type of roaster, cup the results. And that will generally give you a lot of information, right? Last question from an attendee. How drastic is the change of taste profile starting from high PA and then switching to lower PA, closer to crack with lower heat? So the question is, if we do it like an inverted profile versus C, how drastic is the change there? I haven't done that with this specific coffee. I can tell you there will be a major difference. To predict how the difference is without doing it is a bit tough. Luis asks us if we want to simulate these settings without having the software. So you can do this in your own environment without the software by just doing this through your small operator panel on your operator console by just modulating the PA and keeping track of it on a roast profiling log. If you have a first generation Giesen that did not have the PA parameter, then you could simply do this by increasing or decreasing the fan speed. And that's generally works quite well as well. Diligent cupping is always required. Wow, I can tell, all these topics, they raise so many interesting questions. So I just want to tell you, we have at Boot Coffee, we have ongoing e-webinars that we host. You can find the program at bootcoffee.com. So these webinars can be done anywhere in the world from your own leisure, from your own home. We also have a program of learning videos and materials through our affiliated website, coffeecourses.com. And after that time, if you're by that time not tired of seeing my face, then you can just join us for the next Giesen webinar. There will be a recording of this webinar available through the Giesen website. And it was great having you here virtually. Hope we can meet in person. Good luck with your day. Have a great weekend, and we will be in touch. Bye-bye. Thank you, guys and gals. And I hope this will be as great next week. Thank you, Benito. I'm missing Panama as well. Yes. Thank you all, and have a great day. Bye-bye.